Hey guys, this is a recap video on all the stuff we've done on area and volume. So let's get started by having a look at some 2D shapes. First of all, we've got the trapezium. So the trapezium has one pair of parallel sides, A and B, and the perpendicular height between them, or the perpendicular distance between those lines, is h. And your area for this shape was given to you by a half of A plus B, the parallel sides, multiplied by h, the perpendicular height, or the distance between those two parallel edges. Then we had the parallelogram as well, and that was simply base times height. So the area for this one, area is equal to base times height, and that height there must be perpendicular, it must be at a right angle to the base. Very similarly, we have the triangle, and the triangle has an area of a half of the base times the height. So half times the base times the height, or you could say base times height over 2. Sometimes you see it written in different ways, but they all mean the same thing. Then we also had a look at units. Now here you can see if I wanted to know the area of this shape, it would be base times height, but the units are different, so we need to make sure that they're the same. So if I wanted an answer there in millimeters squared for the area, then I would have to do 80 millimeters multiplied by 50 millimeters. They have to be the same unit, and that would give me 4,000 millimeters squared. If I wanted it in centimeters squared, I would do 8 centimeters multiplied by 5 centimeters, and that would give me 40 centimeters squared. Okay, so just remember to be careful with your units there. Also, we looked at bounds. So if I had a measurement, for example here, I've measured something and it's 7 centimeters to the nearest whole number. Okay, the upper bound and the lower bound. So what could it have been rounded from? Sometimes it's helpful here to draw a number line. So you've got 7, 8, maybe down here you've got 6, and where would you round? How would you round to 7? You'd round but from your upper bound and your lower bound. Anywhere in between these two bits here would be where it could have been. So we could have had anything from 6.5 up to just less than 7.5. So we say our upper bound is 7.5 centimeters, and our lower bound would be 6.5 centimeters. Okay. We also looked at these shapes here. These are called prisms. What's special about them is they have the same cross section the whole way through. So here we've got a cuboid, or sometimes you could call it a rectangular prism. We've got a triangular prism, trapezium prism. This one's also a triangular prism, but it's orientated differently, isn't it? It's like standing up there. And the volume for a prism was the cross-sectional area multiplied by the length of it. Okay, so here it is. The volume of a prism was the cross-sectional area multiplied by its length. So that's its length here. Length. We also had circles. Area of a circle we said was pi multiplied by r squared. And the circumference of a circle we said was pi times d. Or sometimes you'll see it written as 2 pi r, because if you had the radius, that is half of the diameter, which is the whole width of a circle. Okay. Then if we know how to work out the area of a circle, we can also work out the volume of a cylinder, because it's a bit like a prism. It's the cross-sectional area multiplied by the length for the volume of a cylinder, but now we know what the cross-sectional area is. It's the area of a circle, pi r squared times the length of your cylinder. We also talked about the difference between volume and capacity. Volume is often measured in these units. A volume is how much stuff you have, whereas capacity is how much you could fit in the container. That was basically the general idea there. And what's next here? Okay, we were looking back at, if we look back at these circles, so we know how to work out the area and the circumference of a circle. I can also work out a section of the circle. Okay, we'll call it an arc. For example, this would be an arc, so it's part of the circumference. Or you could have a sector, and that would be like a slice of cake. Okay, so I could have half a circle, I could have a quarter of a circle, or 3/4 or 1/3, or I could even use the degrees, couldn't I? Because I've got 80 degrees out of the total 360 degrees. And so this would give us a proportion of our circle, or our a proportion of our area, or a proportion of our circumference, so to give us arc lengths or sector areas. Okay, these are the formulas, because basically it's just a fraction of area. Here we've got a fraction of circumference. Okay. We could also look at the surface area of a cylinder. So here we said if we wanted to work out the total surface area for this shape, then we'd have to draw out its net. Okay, so we have to sort of unfold the shape into a 2D picture, and this is what you'd get for a cylinder. You can work out the area of each of the circles and work out the area of the big rectangle here, and then we said that length there was the same as the circumference of the circle. We can also do the same for other shapes, can't we? Like a cuboid, we could unfold it to look like this, and we could work out the total surface area by working out the area of all these 6 rectangles and adding them up. We can do the same for a triangular prism. We could unfold the shape. Notice that this length here is the same as this length here, because when they fold together they need to meet. And you could work out the area of each one of those shapes, and you could add them up together, and that would give you the total surface area of a shape. We also looked at spheres. So if I had the volume of a sphere, it's given to me by this formula here. We just need to be able to use it. So if you've got a sphere and it's got a radius of 2, for example, you'd substitute 2 in here to work out your volume. The same is true for the total surface area. If I wanted the total surface area on the outside, let's say I wanted like paint a football or something, how much paint coverage do I need? I would change this radius here in the formula for whatever it was, and I'd compute this. So 4 times pi times whatever that radius is squared. Okay, we can also do volume of pyramids and volume of cones. So the volume of a pyramid is 1/3 multiplied by the base area multiplied by the height. Quite a straightforward one to remember, and it doesn't matter how crazy my pyramid is. If it's a shape on the bottom and then it meets at the top, no matter what shape it is, if it meets at the top there, it's always the same. It's the base area multiplied by the height multiplied by 1/3. So we can also do the same for a cone. The base area there is just a circle, so we put pi r squared. And we can even do the surface area of a cone. So this one, we just needed to know what this slant's length was. So this is different, isn't it, to the height. This is the slant's length, L. And we need to know the radius of the circle at the bottom, and we just do pi times r times L, and then we add on pi r squared, so we're adding on that circle on the bottom. So this bit here is the curved area, and this bit here is the area of the bottom, and that together gives you the total surface area. So that's a quick look at all the stuff on area and volume that we've had a little look at so far.